Assalamualaikum warahmatullahi wabarakatuh, and good morning to the doctor. So I'm Muhammad Husni bin Hamidi from group expert number 4, which is our group will discuss about the correction on Spt-N number and Spt. So for my group consists of Alif Akil, Hairul Ikhwan, Nur Syafiqah, Lowen Zhao, and Yoh Chin Hong. So about the Spt theory and need for corrections. First of all, Spt stands for Standard Penetration Test, which is the definition number of hammer blows 63.5 kg drop from 760 mm to advance a split spoon sampler 550 mm into salt at the bottom of the borehole, which is the purpose of this test to assess salt density, relative density (dr), and bearing capacity in sense silts. So for the Spt-N number obtained need to be corrected because normally based on 60% energy transferred to the sampler due to depth of sampling, length of rod, size of borehole, time and of efficiency of the hammer used, which is we can get it by this formula, which is N60 equal to EM multiplied by CB, CS, CR, and divided by 0.6 and multiplied by N, which is EM stand for factor for energy use, for CB stand for factor for size of borehole, and CS, CR factor for equipment use, and the last one N stand for spill Spt number. So for the left one, the left table for factor for energy use, which is based on Spt hammer efficiency BNBC 2050 table 6.D.4, which is consists of hammer type, many of hammer type, and also about the hammer release mechanisms. And for the efficiency, for sure it will be different amongst this type. For the left one, for the right one table, we have correction factor for CB, CS, and CR, which is for borehole sampler and rod correction factors. BNBC 2050 table 6.D.5. Based on this table, which is consists of many different of factor such as borehole dia factor CB, sampler correction CS, and also rod length correction CR. And this table also consists of equipment variables and correction factor. So based on this, factors shown above normally applied, which is, however, those factors may vary depending upon the availability from the standards like Eurocode or from manufacturers, which is correction may be made with respect to overburden pressure and is expressed as suggested by Whiteman, Bowles 1988. Which is the left one, we can see the formula M prime 60 equal to N60 divided by square root 100 over sigma prime nut, which is sigma prime nut we can equal to the effective vertical stress and depth of interest, which is for the effective vertical stress and depth of interest we can get by sigma minus pore water pressure, which is sigma stand for total vertical stress due to weight of the soil, and the U stand for pore water pressure exerted by the water within the soil pores. So for the sigma one, we also can get by the gamma multiples by z, which is gamma stand for unit weight and z is stand for the depth. So for the work calculation example and figures, we can see here the SPT is conducted by a sand deposit at depth of 20 meter. Water table is at 8 meter below ground level. If n value is 40, find the correct n value, which is unit weight of sand above water table is 18 kilonewton per meter cube, and saturated unit weight of sand below water table is 19 kilonewton per meter cube. Take gamma W equals to 10 kilonewton per meter cube, which is we can see the flow, how to get the N60 based on the formula EMCBCSCR divided by 0.6 and multiplied by n, which is we can get 46.55 for N60. For gamma prime, we can get by gamma saturated minus gamma wet, which is 19 minus 10 equal to 9 kilonewton per meter cube. And for the effective overburden pressure, we can get by the formula and the answer, which is 252 kilonewton per meter cube. For the sigma prime node, we can get 252 kilonewton per meter cube because of U equal to 0. So based on the calculation, we get for the n prime node, n prime 60, we get 29.32, which is based on formula n60 multiples by square root 100 divided by gamma divided by sigma prime node. So based on the conclusion here, we can get the Spt-N value to N60 is a crucial step in ensuring consistency, reliability, and accuracy in geotechnical set investigations. The raw N value obtained from the field is influenced by several factors such as hammer energy efficiency, rod length, borehole diameter, sampler configuration, and overburden pressure. Without the proper corrections, the N value can lead to the misleading interpretations of soil strength, density, and liquefaction potential. And also the correction to N60 standardize the energy delivered during testing to a reference efficiency of 60%, allowing for meaningful comparisons across different sites, equipment, and investigations. Further adjustments like overburden correction to obtain N1 and 16 Newton enhance the applicability of the data in advanced soil behavior analysis. That's all. Thank you.